So this is a very important video about how we can make the electronic configuration. Let's see. In order to start, we having nitrogen has 7 electrons. What is the correct electron in box representation that has lowest energy? So I would say, so when I start the configuration, how I'm gonna do the configuration? So I say 1s or 2s or 2p. What do I start with? I'll start with 1s, right? This is the first thing that I need to make the configuration for. So I'll start with 1s. And then do I say 1s1 or 1s2 or 1s3? What do I say? Well, I say 1s. Huh? What do I say? Is it 1s1 or 1s2 or 1s3? You can choose which one of them is the correct when you start the electronic configuration. I will say 1s, huh? Yes, you can do it. The electronic configuration is how to see. We don't see one except in one element only. Hydrogen. The only element that you say 1s1 and stop, because it has one electron, you don't have any electron to add. That stop at 1s. Other than hydrogen, any other element you want to do the electronic configuration for it, you have to say 1s2. So hydrogen is 1s1, and any other element you have to say 1s2, including the example that we are having now. So I will say 1s2. This is the beginning of the electronic configuration, and the system of the configuration has to be the same for everyone. All other elements, they have more than one electron. That's why you will say 1s2. Then what do I say? 2s and then 2p, right? This is the same. So I will say, do I say 1s2 and then 1p or 2s or 2p? Which one do I choose? It's electronic configuration. You have to memorize it. So I have to memorize. Do I say 1s2 and then what? 1p or 2s or 2p? You know? Of course, it's not 1p. There is nothing called 1p. In the first shell, in the first energy cell, there is nothing called 1p. So I will say 2s. And I didn't reach to the 2p first. So I don't say 2p, right? I have to make the 2s first. And then after that, I will say the 2p. Okay, let me ask you one more question. If I have 2s, how many electrons do I have? It depends on the electrons that I have in my element. So if I have more electrons, I can say 2s2. If I have 3 electrons only, I will say 2s1. So I don't say 2s1 unless I have 3 electrons in total. So if I have lithium, for example, and I have total 3 electrons, that's why I will say 2s1. But here, any other element after lithium, I will say 2s2. I don't say 2s3 because the s orbital cannot carry 3 electrons. All the s orbitals, either in s or in 1s or 2s or 3s, whatever, they are all maximum of 2 electrons. So if I draw the box representation, this is called the box representation. I will write 2 electrons inside it. So in the 1s, I will draw 2 electrons, and the 2s, I will draw 2 electrons. Also, I never say 2s3 or 2s4 or 2s5 because it can carry a maximum of 2 electrons. So this is the maximum in the s orbitals are always 2 electrons, never more than 2 electrons. Okay, let me see what I will do after that. So I don't say 2s1, I don't say anything. What we are going to do after that, what we are doing after that is that we will see what is our arrangement to have 2 pieces. You have to memorize it. It is 1s2 and then 2s2 and then 2p6 and so on. So do I choose? What do I choose after that? Is it 2s or 2p or 2d? It's 2p. You have to memorize it like that. And the p orbital is a subshell that has 3 orbitals inside it. It's different from the s. Remember, the s, it has 1 orbital inside it, so it can carry a maximum of 2 electrons. In the p here, it has 3 orbitals inside it. So every time I will make the configuration, I will put 6 electrons. It has 3 orbitals, 1 or 2 orbitals or 3. It has 3 orbitals inside the subshell. In the s subshell, it has 1 orbital. In the p, it has 3 orbitals. So how many electrons it contains? It contains 6 electrons. Why 6 electrons? Because in the S it has one orbital and the orbital carries 2 electrons. But here it has 3 orbitals. You see, it's like 3 rooms inside the flat. That's why the maximum the number of electrons that the P can carry is 6 electrons, because every subshell of the 3 carries 2 electrons, 2 electrons, 2 electrons. So the total is 6 electrons. I can draw 6 electrons here. So in the S, I draw 2, in the 1S, I draw 2, in the 2S, I draw 2, and in the 2P, I draw 6. Now, how do I draw the electrons? How do I draw the electrons inside? I have 7 electrons, so I cannot put 2p6. Why? Why you don't put the maximum? Because you ran out of electrons. You have total 7 electrons. You finish 2 in the 1s and 2 in the 2s, and you have out of the 7, 3 only left over. So you have 3 only left over in the. That's why you don't put 6 electrons. You put 6 electrons if you have more electrons, but here you have 7 electrons in total. You finished already 2 here and 2 here, so remaining is 2p3. Again, remember what we said, 1s2, you put here always 2, you never put 1s1 unless you are in the hydrogen element. So you put the 2 electrons. You see the electrons, you don't draw them like this in the same direction. You have to draw them in opposite direction. Why you are drawing them in opposite direction? You have any idea? You put them in opposite direction because you are trying to minimize the repulsion between them. There are 2 electrons and both of them has negative charge. So if they spin in the same direction, if they rotate around the nucleus in the same direction, there will be something called a spin repulsion, because two particles have the same charge and moving in the same direction. That's why there is a spin repulsion. You will try to minimize the spin repulsion by rotating in opposite direction. I will do this also in the 2s. You will draw 2 electrons, and then in the 2p. How do you draw the electrons in the 2p? It's 3 electrons you have to draw according to the Hund's rule, everyone in the separate orbital first. So do you choose option A or option B in drawing? You don't choose option A, because if you put this here, you did not pair, you paired the electrons in the first one. So here in the first one, you have paired the electrons. You don't pair the electrons like that. You have, according to the Hund's rule, draw everyone separate. It's like people sitting in different rooms. You have 3 rooms and you have 3 people. Remember, this is different from the subshell. In the subshells, it's different, because in the subshells, you have to finish the subshell, then go to the next subshell. But in the orbitals, you can fill this orbital, then this orbital, then this orbital, because you have 3 orbitals. Here, I was forced. I have only 1 orbital. But here I have 3 orbitals, so I have to do this with the Hund's rule, so I can minimize the spin repulsion as much as I can. Don't put 2 electrons together unless you have every electron sitting alone by itself. This way I decrease the repulsion as much as I can. This is called minimizing the spin repulsion. So I have how many electrons after the 4? I have total 7. So I put 1 here in px and then py. I don't put it like that and enough. If I stopped like here, there's 6 electrons. If I stopped like here, there is 5 electrons. So I have to put 7 electrons. So I don't put it like that. I put here. I don't put it like that. This is also wrong, because I should have decreased the repulsion in the py. So I put 1 here and I put 1. This is called px, and the second one called py, and this is called pz. So everyone become separately alone. That's why I decrease the repulsion as much as I can. So let's have a look at the other options. So I can see that the A is a nice option, is very good option, but let's have a look at the other options, option B and option C and option C also, D also, if they are okay or not. This is very important to become very good and practice much as you can. Try to make all the elements from the hydrogen until at least 20 or 30 elements, and be very good in the electronic configuration. Is a very important question that comes in the exams, and you must master it. In the second one, I don't find the 2s. I don't find the 2s. There is only 1s, and there is 2p. So we said there should be 1s and then 2s and then 2p. So where is the 2s? There is no 2s. This is 1s and this is 2p direct. So this 2s is missing. That's why it's a wrong answer. In the third one, so let's see. So this one looks, this one is saying where is the 2s? Where is the 2s? This is missing. If I go to the next one, which is option number C, I see that's totally missed out because I have the 1s here. 1s2 is correct, but in the 2s, did you see? The first thing is that I have two electrons here, they are spinning in the same direction, which never happens. So this spinning is too much wrong because it can never be in the same direction. And also he has put the electrons in a very strange way in the 2p. It should not be like that. It should be like in A. And in D, I can see two electrons here. The two electrons are going well in 1s2. Here, where is the electron here? You cannot go to the next subshell. You cannot go to the next subshell unless you have the subshell first. So take care. This is a very confusing rule. So in the orbitals, you can go to the next orbital. So in the orbitals, you can go to the next orbital. You have put one electron, one electron, one electron. You did not finish the orbital. But in the subshells, you cannot go to the next subshell. You cannot go from 2s to 2p without filling the 2s first. But in the orbitals, as long as you are in the same subshell, you can go from the next orbital to the next orbital. So listen to the rule. Horn's rule is telling you cannot move to the next. You cannot put electrons in the same orbital and pair without filling all first the others. But here in 1s in the subshells, you have to finish it first. You have to finish it first before going to the next subshell. The electron here is in an excited state. It has moved from here to here. This excited state happens only if you get too much energy. So if you get too much energy, the electron moves from here and goes here in a state which is called an excited state. But here I don't have an excited state. They said lowest energy. Lowest energy means in the ground state, not the excited state. So if you are in the ground state, the electron will be moving from the ground state to the excited state if you only got more energy. Let's try to make something else like oxygen. Oxygen, how do I make the electronic configuration? So I will start doing the same way. I will put the 1s and then I put the 2s and then the 2p and so on. So let's have a look. Is it A or like that? Do I start with this one or I start with this one? I don't start with this one. I have to start with the 1s like I'm doing always. So I'll put two electrons here, 1s2. Remember, we said 1s1 is in the hydrogen only, so I put 1s2. Then in the 2s, it must be two electrons also. So in the this one is, don't write one electron, it's not hydrogen, it's oxygen. Any element other than hydrogen, I will put two electrons. So I'll put two electrons. This is 1s2, and then I will go for the other one. What is the other one? The other one is 2s2, if you remember, right? 2s2, I can draw the arrow like that, or I can draw half arrows like that. Let's do it like the book. The book is always making the half arrow. So I will draw the half arrow, the two electrons together. Then I will go for the 2s2. Remember, I don't go to the 2s2. Is it three or one room? It's 2s. Is it three rooms or one room? It is one room only, right? So I'll put one electron here. Is it like that? So I put one electron here, no, I have to fill the two electrons here and the two electrons here. So I'll make the spin other electron in the opposite direction. And this also, I cannot go to the 2p and start putting electrons in p unless I have finished all the s, unless I have finished the 2s. The same way, I cannot go to the 2s before finishing the 1s2. So I don't put electrons here unless I have already finished the 2s. This is not allowed. This is not on rule. Don't start putting electrons like that unless you have finished the 2s orbital first. This is totally wrong. Mister, I'm putting the electrons correctly. I've put them and paired them correctly in the 2p. No, but you didn't finish the 2s first. So this is 1, 2, 3, 4, 5, 6, 7, 8 electrons, but we forgot to put the 2s here first. That's why it's wrong. We put the electron here, and then after that, it becomes 1s2, and then you start pairing the other ones and putting the electrons in the 2p. Now it is 2s, so it's correct. And when you make the 2s, it will become 4 electrons. So how many remaining electrons? Out of the 8, there is 4 more. I don't put electrons like that. Hans rule tell me if you are in the same shell, you go by electrons, making them unpaired first. So don't put it like, you first put the electrons 1, 2, 3, and there is one more, so you put number 4. So the total are 8 electrons now. Don't put it like that. You cannot put the electrons in the second one or in the third one before putting it in the first one of the subshell. So this is 3 electrons and 4, 7. So this is the 8th electron. This is the correct way to do it.